It is now time for the Professor Cyril Ponnamperuma Memorial Oration, a tribute to the lasting legacy. Delivering this year's memorial oration is Professor Keerthi, who is known for his work in quantum theory and its philosophical implications. Professor Keerthi is a Sri Lankan scientist with a assortment of research interests in theoretical and experimental physics, chemistry, and biological systems. He is a former director of National Institute of Fundamental Studies and the first professor of physics at the University of Rome. He pursued studies leading to a doctorate degree in theoretical physics at the University of Hawaii. Professor Keerthi has been awarded national honors of the government of Sri Lanka on 2 occasions. Vidyanidhi in 1986 and Deshabandhu in 2005. University of Sri Lanka conferred an honorary Doctor of Science degree to him. He is also a fellow of the World Academic of Science. He was one of the invited scholars to visit the solar cell material and devices group in Beijing, China. So please join me in welcoming Professor Keerthi Thenakoon.
Thank the organizing committee for inviting me to the Symposium on quantum mechanics. Also, event connected with Cyril Ponnamperuma's contribution by his text, and I thank the director for inviting me to the Cyril Ponnamperuma Oration. I will briefly tell what he did. He was radical. Director of an institute like IFS has to be radical. The radical people also make mistakes, also do things. Ponnamperuma did a lot of things, but he also made mistakes. That's natural. He introduced the research culture to the institute. Always talked about the joy of discovery. He was telling that do research, and when you find something original, you enjoy it very much. That is why you should do research. He was telling this all the time. And the greatest thing I appreciate about Ponnamperuma is he consulted knowledgeable people. He didn't do things on his own. He did, but still he consulted. He consulted Sri Lankan scientists, and also the number of foreign scientists, notably Sir George Porter, Nobel Prize winner for photochemistry, and Abdul Salam, theoretical physics. He always consulted. He got publicity to the institute. That is also important. In the beginning, I had a lot of problems. There was no recognition. So he got publicity to the institute. Emphasized seminars, conferences, and public lectures. Exploited political will. That is also important. Otherwise, you can't do much in this country anyway. He was very good at exploiting the political will. Establishment of IFS was a long process starting from mid-1950s. But it wasn't shaky ground for a long time, very, very shaky ground. Cyril Ponnamperuma stabilized IFS. If not for him, it's difficult to say what would have happened. Because it was very difficult to get the political will to physically establish the institute, although the paper there were a lot of things. His strategy, Ponnamperuma, listening to advice of many people, especially Sir George Porter and Salam, decided that viable research projects should be initiated in IFS to achieve recognition. First 2 projects were biological nitrogen fixation. Pulasurya was doing that research, and he requested Pulasurya to join IFS, and then solar energy and photochemistry and solar energy. I was working on these two subjects as a hobby. So I was asked to establish the project on photochemistry and solar energy conversion. It was Sir George Porter who recommended me to Cyril Ponnamperuma to ask me to start this program, although my interest was not photochemistry and solar energy, my interest was mainly theoretical physics. Because of Ponnamperuma, IFS evolved into an institution justified by delivery of publication. They emphasize the necessity of publication to make a mark. International Year of Quantum Science and Technology is an opportunity to consider how we should go beyond publication. In commemorating birth of quantum mechanics at IFS, we should not forget Jayaratnam Elias, intimately connected to the history of quantum mechanics, and he is the initiator of the establishment of IFS. Jayaratnam Elias was born in Jaffna. It's about Paul Lewis Dirac. Dirac was the Lucasian professor of mathematics at Cambridge, chair previously occupied by Isaac Newton. Many described him as only second to Einstein. He was the final founding father of quantum mechanics. He finalized quantum mechanics. Jayaratnam Elias did his PhD under Dirac and researched on quantum mechanics at Cambridge and University of London. A letter written by Dirac to Robert Oppenheimer at the Institute of Advanced Study Princeton was the catalyst that initiated establishment of IFS. This letter written by Dirac, the letter is written from Ceylon. Peculiar thing, but letter is written from Ceylon. I would like to recommend to you, address to Oppenheimer. I would like to recommend you C.J. Elias, who was a research student in Cambridge under my supervision from 1941 to 1944. He was a very able worker and obtained some surprising results about function of electrons, which you probably know about. I should be glad if you accept him in the institute. He would bring new outlook into your discussion. Then he went to Princeton, worked with Oppenheimer, and got interested in the institute and wished that he could establish similar institute in Sri Lanka. Previously, Homi Bhabha, 1953, he established Tata Institute of Fundamental Studies in India. But Bhabha had more political clout, which Jayaratnam Elias didn't have. But in the scientific world, Jayaratnam Elias was more organized than Homi Bhabha. So he had all the strength to establish an institute in Sri Lanka, but things got very much delayed. And got very much delayed. The reason was Elias went accepted a position in Malaysia, and then Mailwagnam was appointed to look into the matter. And in 1969, document was written for the establishment of IFS, first document. But that was implemented only in 19. Report was completed in 1970, and discussions were held in 1972 to establish the institute. And Stanley Kalpage, UGC chairman, was asked to coordinate the matter. And the name suggested for the institute was Institute of Theoretical Studies, so Mathematico-Physical Institute. I just returned from US and accepted a position at Javardhanpura. I was not a member of this committee, but I was asked to participate in the committee. And Mailvaganam chaired the meeting. I suggested the name Institute of Fundamental Studies instead of commemorating 100 years of quantum mechanics. Quantum mechanics is the greatest quantum leap in science. There are other leaps in science, but it took long time from Galileo to Isaac Newton, more than 200 years. From Isaac Newton to Clerk Maxwell, 100 years. Quantum mechanics, just in 25 years, all completed. All completed in the sense that it was fully established. So it's the greatest quantum leap in science. International Year of Quantum Science and Quantum Technology. The General Assembly of United Nations, adopting a proposal by the delegation of Ghana, declared 2025 the International Year of Quantum Mechanics. Activities planned year-round to aim commemorate advent of quantum mechanics 100 years ago and highlight the importance of the subject as the pinnacle of fundamental science and technological promise. Ghana initiative is symbolic because African countries are now awakening to do fundamental science, and all the African countries, almost all the African countries celebrate this event in a grand scale. Sri Lanka is weak in fundamental studies. International Year of Quantum Science and Technology is an opportunity to demonstrate both education and research. What is quantum mechanics? Macroscopic objects, that means objects like motor vehicles, toys, bees, birds, motor cars. Objects of sizes in the scale of elementary particles and atoms and molecules behave differently from familiar macroscopic objects for some unknown reason. Theory governing them extracted from experiment is quantum mechanics. Quantum mechanics is not a derivation. It is some tools extracted from the experiment. Darwin's theory of evolution and quantum mechanics are the two theories that impacted humanity most profoundly. There are so many other theories, but two theories that impacted humanity in the greatest scale is quantum mechanics and Darwin's theory of evolution and quantum mechanics. Now, when it comes to quantum mechanics, everybody thinks that it is something very difficult to understand. You can understand its beyond comprehension. And because of this feeling, a lot of people are reluctant to study quantum mechanics. And even people who study quantum mechanics feel uncomfortable. But the issue relates to the following. The issue relates to our common sense notion of what we mean by understand. What do you mean by understand? Can anyone tell what's the meaning of understand? We understand familiar world by connecting and correlating different things and events. That is what we understand. in day-to-day things, we are not critical about the word understand. You go home and then your wife says something, you understand what he said. Now, when we say chalk is white, child understand. How we understand this concept of whiteness? Child has seen so many white objects. And paper, clouds in the sky, sand, so many things. And for that reason, the concept of white, the child becomes familiar with the concept of white. And then, since he or she is familiar with the concept of white, when he is shown a piece of chalk, he understands that chalk is white. Quantum mechanics cannot be understood in the same way a child understands the concept of whiteness. But nevertheless, it is not illogical. Quantum mechanics is not illogical. If establishment of something by experiment is forbidden, things seem elusive on basis of common sense could happen. Prototype example is so-called double slit experiment. You get Feynman said if you listen to double slit experiment, then that is all about quantum. This is what we mean by double slit. You have two slits cast on a sheet and you place a screen behind it, and then you try to send various things to the slit. If you spray droplets of red ink, you will get an image like this. Exactly a photograph of the slit. If you send bullets through the slit, then you get a thing like this. If the slits are wide and the separation is wide, if you shine light, then again you get something like this. But if the slits are closer to each other, and then if you shine light, you give a pattern like this. That is because waves are, light is a form of wave. And to demonstrate wave nature of light, you don't have to do very complicated experiment. You place two fingers like this and look at the light. Look at the light, you see a series of lights. That is because of the overlapping of light waves, and that is called interference. And the amazing thing is, even if the slits are very small and atomic size, if you send electrons through the slits, you get the same pattern very similar to the pattern you get for light. Even more amazing is, you take a double slit and impinge electrons one by one. Well, not a beam of electrons, impinge electrons one by one. Interval between two electrons can be seconds or even hours. Do the experiment in vacuum. You still get same pattern. Now I saw a real experiment done with double slit. Electrons are sent to a double slit and a photographic detector is placed behind. The spot means where the electron strikes. Point where the electron strikes is shown as a dot. Right now, we don't see any pattern, but as time goes, when large number of electrons goes, pattern is not like bullets going through a slit, but it is very similar to light going through a slit. Electrons go one by one, but still you see a pattern. That means now, how to explain this? when you throw a ball towards two closely positioned windows, ball will pass through either of the windows. If you perform an analogous experiment with atomic-sized windows and propel an electron goes through both. One electron goes through both holes. Electron behaves as if the electron goes through both holes at the same time. Electron is, imagine electron like a ball going through the both windows at the same time. And you can't visualize this. If they, in an experiment to determine through which slit electron pass, you will see pass through one slit, either of them. If an attempt is made to find out whether how the electron goes through slits, you won't get that interference pattern. So what is the problem? Particle behaves as, since you cannot determine whether the electron passes through both slits, particle behaving as it had passed through both slits is not ruled out. Because there is no way to determine through which slit the electrons went. So in that case, in absence of such an measurement, electron behaves as it goes through both slits and nothing wrong in that. But very difficult to comprehend in terms of common sense. But all you have to say is forget about that. That is how it is. So why worry about it? Quantum mechanics is not illogical. And double slit experiment has been performed with molecules. Still you get the interference pattern. Now, for example, glucose molecule going through two double slits. You might think, how can the glucose molecule go through two slits simultaneously? Don't be bothered by visualization. That is when you visualize. When you think that it goes through both sides, it's very hard to believe. It's not like that. No. We can't think about it. It is not that the glucose molecule breaking into pieces, going through both slits and then reassembling to form the molecule. Nothing like that. Glucose molecule, you can't determine whether it goes through both slits. Therefore, it behaves as if it goes through both slits. Nothing illogical, but very difficult to visualize. Dalai Lama is very fond of quantum mechanics. Double slit experiment was done to him. He has no difficulty in believing particles and waves having similar properties, but he didn't believe that he could believe actually that particle goes through both slits at the same time. And it is also a good example for our Buddhists. Tibetan Buddhists are interested in science. When the natural difficulties encountered in learning quantum mechanics. I am not saying understanding quantum mechanics. Adherence to common sense notions. Wrong belief that quantum mechanics can be derived. You can't derive quantum mechanics from classical mechanics for anything. You can't derive. Nobody can derive. Deficiency in mathematics background. Mathematics background is like our mathematics background is very poor because it is only mathematics taught only to people who develop subject and field. Galileo said mathematics is the language which God has written down. Whatever you do, whether it is poetry or biology, mathematics has relevance. Anybody willing and curious enough can learn quantum mechanics. But nobody understands quantum mechanics in the same way a child understands the concept of light. Nobody understands. This is the difference between quantum and classical words. This path to discovered, although quantum mechanics was discovered in 25 years, path to the discovery follows the whole history. It's connected to history of science. Until 17th century, science was largely a collection of facts and partial explanation lacking wide range of predictive capability. First recorded man in the world who thought differently was Sales of Militants, contemporary of Buddha and contemporary of Angulima. This peculiar man from Greece went to Egypt to learn. Egypt was a center of knowledge at that time. He went to Egypt to a monastery and he learned geometry. And at the same time, Angulimala went to Taxala. Taxala was the greatest Eastern university. He studied medicine, traditional medicine, scripture, all kinds of things. And he was versed and said to be very brilliant. Thales went back to Greece from Egypt and said that nature is not the events in the nature are not the works of gods. There are natural reasons, there are interconnections between things. He is the first man to establish the idea of science, correlating things and even linking the experiment. Rational thinking and science originated in West because he's mad. But in the case of Angulimala, he was more teaching there was more spiritual inclined. Everything was spiritual, although he learned a lot of things, and he was not at all rational. Until Buddha intervened and his irrational way of thinking, although he is supposed to be very brilliant, he couldn't understand what is meant by correct way of thinking. And this is the difference between West and East, and it goes until today. And it was Thales' influence that transformed the whole world, and that is why the West is so powerful. Because of the rational thinking, and in the case of East, it took spiritualism. And even now, science is secondary, but spiritual things are more important to us. And whole world changed. And then Galileo went a step further, did experiments and also tried to explain things. Classical physics. This is previous to quantum mechanics. Newton did the greatest thing. He explained motion of things in terms of simple laws, and it has a profound impact. Newton's laws was able to explain motion of objects and also motion of planets. Wonderful theory. It's a remarkable predictive power. Clerk Maxwell did the same thing for electromagnetism. He made a profound theory to explain all known phenomena about electromagnetism. So, early 1800s, people believed that Newton's and Maxwell's theories put together cover everything and nothing exists for them to contemplate deeply. In early 1800s, people thought there's no more to learn. Two theories are there to understand everything. But the hype didn't last very long. In 1902, French mathematician Poincaré proved that Newton's mechanics and Maxwell's theory are mathematically inconsistent. Einstein resolved the problem by introducing theory of relativity. First hint suggestive for need of a new theory was emission of radiation from hot bodies when what is heated, it emits radiation, it becomes red hot and emits radiation. The spectrum of this radiation did agree with the prediction of Maxwell's theory. And Planck assumed that if light is absorbed in as particles in units called quanta, then black body spectrum can be explained. And for that, he need to introduce a new constant known as Planck constant. Planck also noted that constant fills a missing gap in fundamental constants. Now, radiation emitted by the sun will burn everything if the law of radiation behaves according to classical theory. Classical theory about the radiation spectral combustion is wrong. Then photoelectric effect. When you shine light on metals, electrons are emitted. That also could be explained by Planck's hypothesis. This was done by Einstein. He would then have a Nobel Prize for photoelectric effect. Other scientific upheavals in early 1900. Discovery of atomic structure by Rutherford in 1911. And model of the hydrogen atom by Niels Bohr, understanding the spectrum of the hydrogen atom. In 1920, French physicist argued that if waves, light waves have particles have light has particle properties, waves could also particles could also have wave properties, vice versa. That was confirmed by experiments. Hydrogen atom, if you compare, it's a positively charged proton and electron, they attract each other. Very similar to the sun and moon. There is attraction, but classical mechanics couldn't explain the motion of the hydrogen atom, motion of the electron in the hydrogen atom. Both theory gave a partial explanation. It was ad hoc. It explained why electron is not spirated out to the proton. According to the classical theory, electrons should emit radiation and fall down to the proton. It not happen. So we suggested more general fundamental theory different from classical mechanics in some way. Hydrogen spectrum. As students of physics, have you seen the hydrogen spectrum? Can these students tell whether they have seen the hydrogen spectrum? In your physics laboratory, did the teachers show you the hydrogen spectrum? I like to get the answer. But the hydrogen spectrum was shown in the school. It's not in the school in this country, but whether this spectrum was shown in the physics laboratory. In our time, the spectrum was not shown, but we were asked to measure the wavelength of two lights. The spectrum was never shown, but we were asked to measure the wavelength of two lines, and even if you make a slightest mistake, instructor would say that you have done something, you have not adjusted the spectrometer according to the Schuster's method. The spectrum is never shown. And everybody believed that all the lines predicted by the Bohr formula should be in the spectrum, but they are not. All the lines are not there. These things are not told. Spectrum is never shown qualitatively. And some lines are bright. Some lines are bright. Some lines are broad. Some lines are very big. These features qualitatively we don't teach. And we try to teach how to measure it. But Heisenberg was worried about the intensities of spectral lines. and why some lines are broad, why other lines are absent. On November 1933, in 1925, Heisenberg, then a 25-year-old German, working with two famous physicists, Arnold Sommerfeld and Nastron, went on vacation to the island of Heligoland. Leisurely thinking about the problem of the hydrogen atom, he found a radically different way of explaining the emission of light by the hydrogen atom. So, remark. In 1993, awarded Nobel Prize to Heisenberg for this finding was announced. Headline news in all German newspapers around headline news in all German newspapers around 12 noon that day. Heisenberg went home for lunch and sat with his father. Heisenberg's father didn't utter a word about the Nobel Prize. He has read the newspaper, but he didn't want to ask Heisenberg anything about it. Impatient Heisenberg said, "Father, I got the Nobel Prize." Father said, "Just said, I knew you are going to get it." Here, when a son gets 8 distinctions, whatever, we advertise that in the web. And when we write papers, we put our ranks in the web. These are difference. We advertise too much, doing nothing. This is how Heisenberg, yes, there are energy levels in the hydrogen atom, and when that electron is in level 1, it can fall down to any one of the levels, and we found it very different probabilities. And these probabilities he found to be elements of a matrix. Heisenberg didn't knew matrix algebra at that time. It was his teacher, Nastron, told him they are elements of a matrix. And it's amazing how he came to this conclusion, because this 1925 paper, nobody can understand. Very hard to understand. Even the greatest physicists like Fermi, Enrico Fermi, and recent person who highlights the standard modeling for different particles, Weinberg, said they can understand it. Very guesswork, but amazing finding, very amazing finding. Then Schrödinger was a German scientist. He was not promoted to the grade of, although he did great things, he was not promoted to the grade of professor, because according to those rules in Austria those days, character is also. They found some reason not to give the position to, because commenting on his character. But he found a much simpler way to understand quantum mechanics. There's a de Broglie postulate. He wrote an equation, and from the equation, it was later found that Schrödinger's method of for the fluid mechanics is similar to what is exactly same as what Heisenberg did. Then, according to Schrödinger, all the details of a particle is described the quantity called the wave function. And Nastron said it has to do something with the probability of finding a particle. I will not go into details because most students here and not conversant in Western marriage. But it's not necessary. In 1927 Solvay Conference, Brussels, out of the 23 participants, 17 got Nobel Prize. New theory was analyzed and debated. They were not talking about commercializations, patents. Here we all the time they want commercialization, patents, and ultimately nothing happens. But these people were not talking about commercialization. They were above average. Not to talk about those stupid things. But their ideas paved way for thousands and thousands of innovations, patents, thousands of. They were very crazy people, and that's why they were able to do that. Postulates of quantum mechanics. Finally, from the experiments after the Brussels conference, postulates for mathematical formulation was given to the quantum mechanics. First postulate states a particle or system of particles is described as mathematical and carrying all information of the system. Five other postulates tell how to determine exactly. All these were done mostly by four people: Jordan, Camus, Pauli, and Dirac. None of these people didn't understand any condescending matrix algebra at that time. It is said that Jordan, very famous mathematician and physicist, he met the greatest mathematician at the time, Hilbert, in the train going to Berlin. And Jordan asked him whether you know matrix algebra. Hilbert has replied, sometimes I use it to solve differential equations. But they later learned, everybody learned this linear algebra necessary to do quantum mechanics. It's postulates. Consequences of the postulates. There are consequences which are not really present in classical physics. One is called a superposition. The linear combinations of two wave functions of a system are also physically meaningful allowed wave functions. They are physically meaningful. They can combine. To give a simple example, do a hypothetical example. Cats and dogs, they don't obey laws of quantum mechanics. They are macroscopic objects. Suppose they are made smaller and smaller to the atomic size and become quantum mechanical objects. Then they can superpose and form a new species. If you observe the species, sometimes you will see a dog. If you examine the individual of that species, sometimes you will see a dog and other times a cat. Randomly, but with definite probability. It's random, but sometimes you can see a cat, sometimes you can see a dog, but with different measurable probabilities. They can mix up. Entangle. The other thing about, I think, Thenakoon will talk more about these things. I will just briefly mention. There are two brothers. Two brothers always wear either a blue or a red shirt. They do it randomly. One day, boys decided both would not wear the shirts of same color. They decided that one wear red, other will wear blue. Agreement can be implemented when they live together at home, but not when they go to a boarding school miles apart. If they don't have cell phone. It's very unlikely these days. If the boys are quantum mechanical objects, the agreement is called entanglement, works automatically and instantly without any communication. That is called entanglement. Peculiar principles following from postulate of quantum mechanics is entanglement. Two particles correlated to each other by some properties mean that correlation is separated far apart. Entanglement, rare instance where Einstein went wrong. Einstein didn't believe in entanglement. He said entanglement means sending information from one particle to another, even light years apart, instantly. It said it is impossible. Only things can move at the speed of light, therefore, entanglement is not possible. There was headlines in New York Times 1935, Einstein had a quantum mechanics. This one instance where he went wrong. But Einstein forget that information can be considered because changing from one state to another state in this object is random. So how can you send information? Just send information. So zero relativity is not violated. Quantum computers. Computers are classical computers are based on the bits and one. But in the case of quantum computers, they are based on qubits. They take not and one, but just like the cat and dog, they can take the other value. And they say that the superfast computing is possible. And some examples are already there, only they are not very stable. Superfast quantum simulation enables discovery of new drugs, triggers, and understanding. That's what the say. And we will talk about a thing called the quantum supremacy. Computer theorists talk about quantum supremacy, meaning that quantum computers could solve problems beyond any conceivable classical version. Yet, supremacy of the human brain could not be defeated. Truly original ideas originate only in the human brain. If AI came first, it would not discover quantum mechanics. From AI, you can discover quantum mechanics. Maybe you can discover better drugs, complicated things, machines, but you never have discovered quantum mechanics. Quantum field theory is the most successful theory. It is a combination of special relativity and quantum mechanics. Today, the model of elementary particles known as the value model is based on this theory. Predictions are 100% correct. Scope of quantum mechanics. Scope of quantum mechanics is so wide, it covers elementary particles, atoms, molecules, chemistry, astrophysical phenomena, and find applications in electronic devices, material science, instrumentation, synthesis of chemical substances. In the latest, the new technologies based on superposition and entanglement. Known and unknown. There are all the predictions of quantum mechanics. None of the predictions of quantum mechanics have been falsified by itself. But there are unsolved problems. Major problem is we have the family of which we call the classical world. Classical wave doesn't like behave like quantum world. If the classical world behaves like the quantum world, man can go through two windows at the same time. If you go through a window, you get an interference pattern. Those things are not happening. So there is a demarcation between classical and quantum worlds. How it happens exactly is not known. And also, we don't know how to connect gravity to quantum mechanics. The other problem is elementary particle theory contains so many unknown parameters. We don't know how to calculate. We don't know how the laws of quantum mechanics originate. But definitely, life would not be possible without the postulates of quantum mechanics. There is a story, unwritten story. God declared he would give an appointment to a representative from Earth to ask two questions. Humans nominated Freeman Dyson of the Institute of Advanced Difference to meet the board. One of the questions was why God framed laws of quantum mechanics. God refused to answer. There are other versions of this story which says God answered the question about the theories of quantum mechanics, and the second question was about the turbulence. Why the fluids turn turbulent when the velocity side. God refused to answer the second question. If a Sri Lankan was nominated, he would have asked whether the laws of quantum mechanics could be amended. We are in the habit of amending the constitutions and the acts. Constitution also amended several times. To the time, amending acts to several percent. Should Sri Lanka go for quantum mechanics? Certainly yes, but not prematurely. It won't be a success. Transformative technologies emerge as results of fundamental research initiated out of university by ingenious brains. When such investigations carried out in foreign lands lead to technological commercial potential, we grab them prematurely and propose introducing them from kindergarten, stupidly expecting economic returns. But nothing has happened. Now, very soon they will say that we have to introduce quantum technologies, teach them in the schools, and then commercialize. Grabbing new technologies. Once it was biotech, then nanotech, now AI. Very soon, people will say, or quantum technology because it is more promising. Have these officially supported efforts delivered well recognized innovation? Not a single. Nothing out of the official. In trying to commercialize everything under the sun, nothing really gets commercial. Nothing has happened. To embark successfully on new technologies, teach basic science and do research in the area. If basic science is not properly, mathematics is not properly taught. Syllabi are adulterated syllabi nowadays. That is again with the intention of commercialize. Applied mathematics syllabus those days was very powerful. Our applied mathematics. The books we use, most of the books we use nowadays for applied mathematics and mathematics were books written by Loan, man called Loan. There was a recent news item which says that the present generation and the previous generation, all the leading scientists and the engineers are the people who learned mathematics from those books, old books. But now, today, we have revised our syllabi and adulterated, I would say, thinking that it will help industry and everything, but nothing has happened. We are going backwards. Now, researchers engaged in fundamental research should not be compared to obtain commercially viable instant results. Nowadays, the ministries ask for reports from what you are doing. In 1 month. How can you do something in 1 month? That kind of thing will not do anything, and people should be allowed to do things freely. To take the example, the two institutes in the world that has produced greatest innovations in the world in the recent times is Institute of Advanced Study, Princeton, New Jersey, and the Institute of Molecular Biology, Cambridge. In those two institutes, the researchers have no rules. They are given free time to think about anything, but best people are recruited and they are to think freely. And those two other institutes which have generated the greatest innovations in the world. They are not asked to send reports. They are free to do anything, free to talk. Controlled by the government, by the European. Fundamental research cannot be done that way. And this is a mistake we are doing. Compared to the countries in the region, we are extremely weak in fundamental studies. Compared to all the countries in the region, Nepal is doing better. Now, if you examine the people who are teaching, the young teachers who have been recruited to academic positions in physics in United States, there's a quite number of people doing physics, getting scholarships in American universities from Nepal. Reason is that they do teach physics, use the standard textbooks, they teach everything in the proper way. Subjects like quantum mechanics, classical mechanics, mathematical methods, taught properly. They go to United States, follow advanced courses and do extremely well, and they do so well that most of them are getting positions in American universities. One man who is working on this International Year of Quantum Mechanics in US, in Caltech, his name is Adhikar. He's from Nepal, working in Caltech. So, Sri Lanka has to revise and the way the subjects are taught, and we try to mix up. Thinking that certain subjects are relevant for commercializations and industries, they skip basic science, but nothing happens. Now we have a university dedicated to value addition of minerals. Value addition of one university, the motto is value addition to minerals. But solid state physics and quantum mechanics made that process are not taught. Although we have been going on for more than 3 decades, I think, still we export rare minerals and graphite raw, no value addition. There is a university dedicated to value addition too, but still we export graphite. Better research on these subjects are done in IF. But the university, I don't think anything has happened. But the put of the university is value addition to material. Nothing else. We still export rare earths. Now, right now, there's a big issue regarding rare earths. China, US, recent relationship entirely do with rare earths because we have rare earths and freedom. There is sense. Nothing has been done. International Year of Quantum Science and Technology is an occasion for us to recollect how fundamental studies have transformed the world intellectual and technological, and plan our policies in education and dissemination of knowledge. Dissemination of knowledge is important to attract younger people to this. Now in Sri Lanka, very few people go for science. They are not attracted to science because current thinking in the country all the time saying that you should do something nationally important, but all the nothing. And because of that, and the policies, allocation of funding, we are not going in that direction. I hope that the government will consider these things in this year. Alternatively, compared to African countries, there is nothing much happening in this country, in this area. This celebration of the International Year of Quantum Mechanics. I thank IFS for initiating this symposium and giving me an opportunity to deliver Ponnamperuma Oration in this occasion, because this is what the other institution in the country should also be doing. Thank you. I'll stop here.